Alright, so now we're starting a new section, and we are factoring trinomials of the form x squared plus bx plus c, and the difference of two squares. Okay, so what factoring means is it is undoing the multiplication process. So now, where we were last unit, multiplying these guys out to get this, now we're starting with this and turning it into that. So that's called factoring. Okay, I'm going to give you a second to read through this, and then I'm going to show you an example, and we will discuss how to work this problem. Alright, so let's take a look at this problem. So the question is, I want to factor x squared plus 6x plus 8. Now, I'm going to show you something that it really won't make a whole lot of difference today, but tomorrow it'll make a huge difference, or in the next video. So what you want to do is you want to take this leading coefficient. What is the leading coefficient? Well, in this case, the leading coefficient is 1, and you multiply it times your constant term, and you write it down off to the side. Now I'm going to write down all of my factors, or my pairs of factors, that multiply to be 8. So I've got 1 times 8. I've got, don't forget your negatives here, those multiply to be positive 8. I've got 2 times 4, and I've also got negative 2 times negative 4. Now I'm going to ask myself, which one of these pairs adds up to be positive 6? Now where do I get that from? I get that from right there. So 1 plus 8 adds up to be positive 9. Negative 1 plus negative 8 adds up to be negative 9. 2 plus 4 adds up to be 6. And negative 2 plus negative 4 adds up to be negative 6. There's only one of those pairs that adds up to be positive 6, and that is this one right here. So this is how this factors. I've got x plus 2, notice how that's a positive 2 right there, times x plus 4. It's a plus because this is a positive 4. And there you go, you've just factored it. Okay, I'm going to give you just a second to read through this. You might want to hit pause. Alright, so let's take a look at this one. So again, doesn't make a whole lot of difference today, because today our leading coefficient will be 1 every single time. Tomorrow it won't be. But I'm going to do 1 times 36. I'm going to write it off to the side. Now I'm going to write down all the different pairs of factors of 36. I always start with 1, even though I know in this case it's not going to be useful, but I always start there. Then I go to 2. Three, 4, 5 won't go in. Alright, there's all the pairs of factors of positive 36. Every one of these multiplies to be positive 36. There is only one of them that adds up to be negative 12. Now where do I get negative 12 from? The negative comes from right there. The 12 comes from that middle term. So look, if I add these up, 1 plus 36 is 37. Negative 1 plus negative 36 is negative 37. 2 plus 18 is 20. There's negative 20. There's 15. Negative 15. There's 13. There's negative 13. There's 12. And there's negative 12. So look at that. These are the only ones that add up to be negative 12. So this thing factors to be x minus 6 times x minus 6. Or you could write it like this. Those are the same thing. I would accept either one of these for full credit. Okay, again, I'm going to give you a second to read through this. You might want to hit pause. Alright, so now, same process still applies. So I'm going to do positive 1 times, in this case I'm going to do negative 20. See the minus sign in front of that? Let me erase it. So you see the minus sign there. So 1 times negative 20, and I'm going to write negative 20 off to the side. So now I want to write down all the different pairs of factors of negative 20. So I've got 1 and negative 20. Those guys multiply to be negative 20, right? Or I could have negative 1 and positive 20. I could have 2 and negative 10, or I could have negative 2 and positive 10. 3 won't go in. I could have 4 and negative 5, or negative 4 and positive 5. And that's all the pairs of factors of negative 20. So now I want the one that adds up to be negative 1. So the top one adds up to be negative 19. The second one adds up to be positive 19. 2 plus negative 10 is negative 8. Negative 2 plus 10 is positive 8. 4 plus negative 5 is negative 1. Negative 4 and positive 5 is positive 1. There's only one of these that adds up to be negative 1, and it's this one. So this thing factors to be W plus 4. Where do I get the plus from? Because that's a positive 4. And W minus 5. Alright, so let's take a look at this. This is really not done any different just because we have an x and a y. We're still going to take this leading coefficient of 1 and multiply it times the last term. 1 times 6 is 6. So the pairs of factors of 6 are 1 and 6, negative 1, negative 6, 2 and 3, or negative 2 and negative 3. 1 and 6 add up to be 7. That adds up to be negative 7, that's 5, and that's negative 5. And what are we looking for? We're looking for positive 5. So it's going to be these guys right here. Now, here's what I want you to realize. You still only want to have an x and an x there, okay? But at the end, you want to make sure there's a y and a y there. So I want a positive 2 and I want a positive 3. Now, with all of these factoring problems, you can actually check your work. So let's try that. So how you check your work is you multiply, you distribute, just like you did before. This right here is our answer, but if we want to check our work, we can multiply it out off to the side. X times positive 3y is positive 3xy. 2y times x is a positive 2xy, and 2y times 3y is a positive 6y squared. There's our like terms. Oops, forgot that. There we go. Alright, so because we wound up with what we started with, we know that this is correct. Alright, so the definition of a prime polynomial is where we can't find, whenever we multiply that leading coefficient times that constant term, and we add all of the pairs up, then what will happen is none of them will add up to be the middle term. That means you have a prime polynomial. Okay, so let's say that you have a problem like this. Check this out. It is not written in standard form. I strongly recommend that you change all of these into standard form before you ever start working with them. So this I would rewrite like this. And now I'm going to take my leading coefficient of 1 and multiply it times the negative 15. So I get negative 15 off to the side. Now I'm going to write down all the different pairs of negative 15. I've got 1 and negative 15. Negative 1, positive 15, 2 won't go in, 3 and negative 5, or negative 3 and positive 5, and that's all the pairs. So now I'm going to add up each of the pairs. I get negative 14 here, I get 14, I get negative 2, I get positive 2. Not a single one of them add up to be negative 3, or positive 3, I'm sorry. So because none of these add up to be positive 3, we would say that this is prime. That's our answer. Okay, so read through this real quick and then we're going to talk about it here on the next page. Okay, so last time whenever we were multiplying things together, the only way that our middle term ever dropped out and went away is when we had a conjugate pair. Do you remember a conjugate pair looks something like this? And what happens whenever you multiply these guys out, you get a middle term that turns into 0. And these guys cancel because one's positive, one's negative. So you wind up with a squared minus b squared. So this is a conjugate pair. Your middle term drops out on conjugate pairs. So every one of these problems are also conjugate pairs because notice our middle term is missing. So what you do in order to factor these is you take the square root of that, put it there and there. Take the square root of this. What's the square root of 16? It's 4. Put it there and there. And one has to be a plus, and one has to be a minus. I always get this question, does it matter which one you write first? No, not at all. You could write your minus, then your plus, or you could write your plus, then your minus. It does not matter. Just one or the other. You don't have to write them both down. Alright, so take a look at this. Take the square root of 9m, you get 3m, put it there and there. Take the square root of 4, ignore the negative, take the square root of 4, you get 2 and 2, and remember one is a plus and one is a minus. Okay, so check this out. Take the square root of 25p squared, you get 5p, you're going to put it there and there. Take the square root, ignore that sign, of 49q squared, you get 7q, and one is a plus and one is a minus. And you're done. Alright, so this is a good warning, and this is where people always mess up. A polynomial of the form x squared plus k squared, where k is not 0, is prime. So if you have x squared plus 25, this thing right here is prime. It's the minus that makes it a conjugate pair, or makes the factoring a conjugate pair. But whenever you have something like this, so if you have, let's say, 36x squared plus, let's say 144, this would be prime. But if you have 36x squared minus 144, now you have 6x and 6x go there and there, 12 and 12 go there and there, one's a plus, one's a minus. So this right here is prime, but this right here factors to be 6x plus 12, 6x minus 12. Alright, I hope this helps. Have a good day.